Welcome to today's episode on IQRF technology. Today we will look at it from the perspective of local autonomy. Why should this be interesting? What does it mean when a system works on its own?
Local autonomy is actually a key feature of IQRF. It is related to savings and security. The systems do not necessarily have to depend on any remote services.
Okay, cost savings, that sounds logical. So apparently there is no monthly fee for these remote services.
Exactly. But it's not just about fees. The network can operate completely independently locally, using reliable and secure IQRF wireless communication. So the owner has everything under control, the costs are predictable, and they are not dependent on a third party.
And that security from the perspective of local autonomy is related to the fact that the system does not need to be directly connected to the internet, which dramatically reduces the risk of external attacks. All the data, the entire control system, remains secure, let's say, at home. It's like having your own closed circuit. This is absolutely essential for critical things.
The system can function as an isolated island, completely autonomously. But when you need to send data somewhere or remotely control elements in the network, you can easily connect to the network via a so-called IoT gateway, which is actually a device that connects the local IQRF network to the outside world, for example via mobile data or some other means. So the flexibility is still there.
Let's look at some examples of where this is actually used. These applications nicely demonstrate the power of this approach. For example, deployment in critical infrastructure, such as power plants. One case study on the IQRF Alliance website talks about controlling the tilt of turbine blades, which is a very sensitive matter where you need 100% reliability.
Definitely. In general, the advantage of local autonomy is significant in industry. Another case comes from a car manufacturer, where reliable data transmission from torque wrenches during car assembly is mentioned. Other cases refer to the control of heating and lighting in huge factory halls. There, too, reliability and savings are important.
And then there are more extreme cases. For example, collecting data from sensors on a remote island. There is simply no stable internet connection available there. The only option is to use local control and monitoring.
Local autonomy is basically a necessity there.
So the applications range from critical systems to manufacturing, to places that are literally cut off from the world. What about more common projects in buildings and cities?
For example, lighting control, whether normal or emergency, or public lighting in cities. Then there are heating, ventilation, and air conditioning systems. And, of course, data collection from various sensors, such as temperature, humidity, air quality, and other variables that we simply need to know. Reliable and secure control of various devices and machines directly at the given location, which may not be connected to the internet. But when necessary, it is possible to cooperate with remote systems.
And I'll come back to the security, which is a necessity everywhere. How exactly does it relate to local autonomy?
Very closely. Of course, a system that does not necessarily have to be connected to the internet logically has a much smaller attack surface. There is no risk of attack from remote networks, which is one of the main threats today. So, in this respect, local operation simply means safer operation.
So, to sum up, local autonomy in IQRF brings an interesting mix of benefits. First, it saves costs, gives full control over the system and data, and also increases security. And all of this is especially valuable in critical applications, in industry, or in places where network connectivity is unreliable or even undesirable. Thank you for your attention, and we look forward to seeing you in the next episode of our podcasts.